Okay, ladies and gentlemen, here is our book, Curiosity, the Story of a Mars Rover. This is by Markus Motum. I hope I'm saying his name correctly. And there we have The Red Planet, the story of the Mars Rover. Wherever you are in the world right now, I am a very long way away. I'm not even on the same planet as you. I'm a Mars rover. A rover is a moving robot built to explore far off places, places too far away or dangerous for humans to visit. How did I get here? Why was I sent? This is my story. Humans have always wondered about Earth and its place in the universe. Although scientists have made great discoveries and explained some of the mysteries of space, the planets hold their secrets well. Many questions remain unanswered. Of these, one question intrigues humans above all others. Is there anybody else out there? Scientists decided that the best place to look for other life was on one of our closest neighboring planets, Mars, the red planet. In addition to being one of our closest, here I'll show you Mars as I read, one of our closest neighboring planets, Mars is the planet in our solar system that is most similar to Earth. Scientists think that in the past, Mars may have had environments similar to the ones on Earth today. Mars is covered in red dust now, but there is evidence that millions of years ago, the planet may have had lakes, flowing rivers, and even great oceans. Why does this matter? Because on Earth, water is a necessity for life. However, there is one problem. The trip to Mars in a spacecraft can be over 350 million miles, a distance that's much, much farther than any human has ever traveled in space. Even with our modern technology, we don't have a practical way to get humans to Mars. The journey would take at least 6 months, or to get them back. So you could go to Mars, and here we are on Earth, and up here in the very corner is Mars. We could get our astronauts there. The problem is we couldn't get them home. Humans have been able to explore closer to home. On July 20th, 1969, Apollo 11 landed on the moon. Astronaut Neil Armstrong took one famous step and became the first person to set foot there. For a few hours, he and Buzz Aldrin walked on its surface. People could look up at the moon and know that someone might be looking back at them. Mars is about 200 times farther from Earth than the moon, a journey that is currently very difficult for humans to undertake. The red planet is also in an inhospitable environment, meaning it's not very good for us. But what if it were possible to send an explorer who didn't need food, water, or oxygen? See, those are the three things we need: food, water, and oxygen, and they're not on Mars. That is where I come in. Who? We're talking about curiosity. So if you notice, here's an astronaut. An astronaut needs a lot of things. They got to have the radio in the backpack, a gold visor to protect from the sun, a life support system, a control module showing oxygen levels. We need oxygen tubes. I mean, this was all needed for the Apollo astronaut when he was landing on the moon. But a rover doesn't need oxygen. It's got solar panels to use to power early rovers. It's got a camera. It's got wheels that are able to drive over rough terrain. Scientists at NASA, the National Aeronautics and Space Administration, came up with an idea to send robots to Mars in humans' place. The robots would be able to cover more rough terrain with all the equipment needed to collect data and samples. So the scientists began to design rovers like me. This is an early rover, if you are. And see, here we are designing, making our decisions. So the project to build and design Mars rover was and still is based in the Jet Propulsion Laboratory near Los Angeles, California. I needed to be larger and more advanced than any of the rovers NASA had built before. Previous successful rovers had taken photos of Mars, giving NASA never before seen images. Other missions were orbiters or flybys, flying around or past Mars to gather information without even landing on the planet. By 2007, 39 missions to the red planet had been launched, and over half had ended in failure. So think about that, guys. 39 rounded up to 1, you get 40. Now take 40 and cut it in half. So 20 of them, 20 were failures, and 20 were good. I'm not so sure if that's good odds. Some of these earlier missions had become lost in space, while others crashed into Mars, never to be heard from again. I wouldn't want to be the guy who crashes, even if you are a rover. The lab where I was built had to be kept as clean as possible. Everyone had to wear white coveralls, which were nicknamed bunny suits. These suits stop dust and germs from spreading to me and my equipment. The suit covers a person from head to toe. This way, no skin, hair, or other kinds of human dust will be shed in the clean room. Humans make a lot of dust. These air showers, they blast away dust and hair and skin from the coveralls before people enter. Static electricity, if you've ever gone across carpeting and then shocked somebody, can harm equipment. So this cord keeps the team member from giving off static shock by transferring any static charges to the floor. And of course, there's filters to remove as much dust in the lab's air as possible. And this is where we create the magic. The team didn't want to think they had discovered tiny life forms all over Mars, only to realize it was just Earth bacteria I'd brought with me. So they recreate the Martian environment in test rooms at the lab so they can check that he was prepared. Or actually, we call it a she. The wheel system was designed to keep all 6 wheels in contact with the ground. That way he can't tip over on any terrain it could encounter. And there you see the men in the bunny suits and the women in the bunny suits checking it all out. Early new technology had to be invented for my mission. Entirely new technology had to be invented by my mission. I needed to be able to carry a lot of equipment to test what I found on Mars, my own portable laboratory. To give the mission the best chance of being successful, years of testing were needed to make sure everything would work correctly the first time. After all, if something were to go wrong on Mars, no one could come and fix me. So if you're wondering, it's about the size of a small car. So it's got an antenna to communicate with us on Earth. It has a weather station, so it can record wind speeds, temperature, and radiation. It's about 10 feet long, about 9 feet wide, and about 7 feet tall. There is a camera that points downward that films the ground so that you can see where it's going to land. And then there's these hazard cams, or HazCams, and they're used to spot and avoid dangerous terrain so it doesn't get stuck in a hole or anything. Now, NASA ran a competition for members of the public to choose the name for me. Some of the names considered were Adventure, Journey, Pursuit, Vision, and Wonder. The winning entry was submitted by Clara Ma, who was a 6th grader from Kansas. The name she picked for me was Curiosity. So just so you know, it also has an onboard chemistry lab where it runs all the science experiments. Like I said earlier on Perseverance, it does have a shoulder, an elbow, and a wrist, so it can be flexible. There is a battery on Curiosity. It's nuclear powered, and the plutonium in there is lasting now for 10 years. There's a robotic hand that has lots of tools, including a drill and a brush. And there's wheel treads on the wheels, and that leaves marks to help them figure out how far Curiosity has traveled. Now, when it was ready to take off and to fly to Mars, it was best to launch me eastward and close to the equator, so I can get as much energy from the Earth's spin as possible. This also meant it was safest to launch where the ocean was to the east, just in case something went wrong. So I had to be taken to Florida to begin my space mission, and I boarded a carrier plane, and I flew from Los Angeles to the Kennedy Space Center. Now, the rocket that would take me into space was waiting for me in Florida. The Atlas V rocket is about 200 feet tall, the height of a 19-story building. It is almost all rocket fuel. This is because it needs to be powerful enough to launch whatever it's carrying, known as its payload, into space. Atlas V is known as an expendable launch vehicle, which means its parts can only be used once. I was placed inside the nose cone at the very top. The cone is like a shield that protects the rest of the rocket as it breaks through the Earth's atmosphere. Now, my launch date was chosen very carefully so that I had the best chance of a successful launch in the shortest trip possible. Because the planets orbit around the sun at different speeds and distances, sometimes they are far apart and other times they are much closer together. Every few years, Earth and Mars are lined up so that they are relatively close, allowing missions to reach Mars more quickly and using less fuel. If we had missed this opportunity, the mission would have been delayed for years. Here is mission control. Launch day, November 26, 2011 arrived. I was ready to fly to Mars. In the control room, the team ran through the final checks. At last, the rocket was ready for countdown. 5, 4, 3, 2, 1, and we have liftoff. There it goes. Now, the first part of my journey was breaking through the Earth's atmosphere and reaching space. Once Atlas V's various boosters had done their job of getting the rocket into space, they broke off and fell safely into the ocean. So if you notice, there were 4 little boosters that were on the side. Let me go back and show you really quickly. So here we have, there are our boosters, okay? There's 4 of them, and then this red part, orange part is what we're going to talk about next. So the 4 boosters, okay, that help the main rocket escape Earth's gravity, then fall back to Earth and fall into the ocean. Now, this is the common core booster, and it's in its engine. It's about 107 meters long. Its fuel tanks were filled with kerosene and liquid oxygen. This, too, is going to fall back. Once the rocket has carried me safely into space, the nose cone, here we see this, right? It broke off and fell back toward the Earth. And then the common core booster detached. Next, a smaller engine burned its fuel to launch me out of the Earth's orbit. 40 minutes after liftoff, that engine detached, and I was headed towards Mars. I made the rest of the journey in this protective shell called the module. The module used its star scanner and sun sensor to guide itself. Thrusters on the outside of the module could change the direction when necessary. They were the only part of the rocket that made the long journey to Mars with me. After 253 days hurtling through space, I finally arrived near Mars, traveling 13,000 miles per hour. That's super fast. We don't have cars that go that fast. Could you imagine that? Next would be the trickiest part of my entire journey, landing safely. And there is the module. And now it's going to land. And this is what we call the 7 minutes of terror, ladies and gentlemen. No rover or space mission had ever tried the type of landing I was programmed for. It would take 7 minutes from the time I penetrated the atmosphere around Mars until I landed on the surface. The team at NASA called it 7 minutes of terror. If I had been landing on Earth, the atmosphere would have slowed down my entry. But Mars has much less atmosphere, remember, no oxygen, than our home planet. So as soon as I entered the atmosphere, a huge parachute opened, slowing me down to about 200 miles per hour. So here we are with the heat shield entering Earth's atmosphere. I was traveling more than 1,000 miles per hour. The metal heat shield protecting me heated up to 3,800 degrees Fahrenheit. The heat shield fell away, allowing my radar to determine where I should land. A huge parachute slowed me down to about 200 miles per hour. And there's the heat shield falling off. Now, the back shell has this. I was still moving too fast, so I dropped out of the back shell, and for a few minutes I was free falling to the ground. Suddenly, the powered descent vehicle which was holding me fired 8 rockets, slowing me down almost completely. Then I was ready to be lowered to the surface on cables known as the sky crane maneuver. Once the descent vehicle detected slack in the cables, it knew I must be on the surface of Mars and release the cables. Now, so the back shell detaches, and the powered descent vehicle retro rockets fire up, and it makes a sharp turn because it doesn't want to crash into this. That would be bad and mess it up. So then it flies off into a safe area, and now it's only traveling about 2 miles per hour. That's lower than a chicken, by the way. About 60 feet above the surface, and the sky crane cables lower me carefully to the surface. Once the descent vehicle senses that he's on the ground, it cuts the cables and flies away so that it won't land on top of me. So literally, we're throwing a lot of junk around Mars right now. I had made it. As soon as I was safely on the surface, I sent a message. I'll let you look at the rover there. Sent a message to my NASA team letting them know that I had landed. Because of the huge distance between Mars and Earth, the message took 15 minutes to get back to Earth. It was a tense time in the control room as everybody waited. Then the words everybody wanted to hear were read out. Touchdown confirmed. We're safe on Mars. Everybody's cheering. It wasn't just the NASA team who had been watching my landing. All around the world, people tuned in to see if I had arrived safely after my long journey. Crowds gathered in New York's Times Square to watch on a giant screen. It was exciting but scary time. After all, if just one thing had gone wrong, all contact between me and the team back on Earth would have been lost. When they had heard I'd landed, some people cheered, others breathed huge sighs of relief. The next thing I did on Mars was send pictures of myself back to NASA. Yes. She takes a lot of selfies, if you will. So the next thing she did on Mars was to send pictures of myself back to NASA to make sure I hadn't been damaged during the journey. My landing had been perfect, if a little dusty. The site had been carefully selected by scientists as a place likely to have evidence of water. Now it was time to start looking. Since 2012, I have been exploring Mars. The NASA team looks through my 17 cameras and chooses potential spots on the surface that may have evidence of life. Once something is identified, I move toward it. I can move more than 600 feet per day. So that's the difference between Mars. It was looking for potential spots. Now the other one is actually going to be looking for those life forms, microbial life forms, I believe. NASA also wants to understand how Mars was formed and how it has changed over time. The deeper I dig, the more information I can gather. I drill into rocks and scoop up material, then I test it on my onboard laboratory. Gradually, by piecing together information from different locations, NASA hopes to build a picture of the planet's past and perhaps discover why Mars changed from being a warm planet with water, like us, to the cold, dry planet it is today. So it takes photos with the navigation and hazard cams and combines what he sees in the pictures to make a safe route around Mars because it's got to make sure he's safe. As a hole is drilled, the powder gets sent up into a tube in my arm, and then my arm reaches over and places the powder in the laboratory for testing. She can fire laser at rocks and helps NASA find out what they're made out of. There we have it. There are many questions still to be answered. What was Mars like long ago? How suitable was it for life? Did it once support any life forms? The tests I carry out will provide as many answers as possible. Most likely, the discoveries I will make will lead to more questions. With space exploration, questions can be just as exciting as the answers. Thanks to the curiosity of explorers, Neil Armstrong's footprints are on the moon, and now my wheel tracks are being left on another planet. Perhaps one day soon, footprints from the next generation of explorers will leave their mark on here as well. Curiosity is the passion that drives us through our everyday lives, and there it is. We have become explorers and scientists with our need to ask questions and to wonder. We will never know everything there is to know, but with our burning curiosity, we have learned so much. And that is from Clara Ma, the 6th grader who named Curiosity. Now, you might be asking me, wait a minute, Mrs. Nielsen. Who named Perseverance? Well, that was a 7th grader on the East Coast. I want to say West Virginia or Virginia, and he won the contest. So While Curiosity is the most advanced rover sent to Mars so far, she's not the only rover to explore the red planet. In 1997, Sojourner rover was the first to land successfully on Mars and remained active for much longer than expected. It was nearly 3 months before Sojourner sent her final transmission to Earth, so she only made it for 3 months. The Mars exploration rover Spirit was the next to take a successful landing in 2004. She survived much longer than she was expected to and made an amazing discovery that there was once water on Mars. After traveling nearly 5 miles over 5 years, Spirit got stuck in the dust and eventually lost contact with Earth. But Spirit's twin rover is still operating today. Opportunity landed 3 weeks after Spirit, and since then has traveled farther than the length of a marathon. No robot has ever gone so far on the surface or another world. Opportunity continues to explore Mars crater and send back many images. But here's the problem. I think Opportunity fell into a hole. Oppie is what they called her, and she no longer sends anything. So right now, the only one that we have sending information back is, and this one is Curiosity, right here. Okay, so that is still working and still sending information. Now, I can't remember. One of the students had asked me, why do we call it, why didn't we come up with a boy's name? Or why do we call it a girl? And I can't remember, but most machines, I can't remember where I read it, boys and girls, but machines are cars and ships and boats are named after women. So we refer to Opportunity, Spirit, Curiosity, and now Perseverance as girls. And if I figure out where I saw that, I will let you know. But yeah, that's the way it goes. Sorry, guys. They're girls. So I hope you enjoyed the book. Remember that tomorrow, we have the landing tomorrow at 1:15 approximately. There it is, Curiosity, the story of the Mars rover. So tomorrow you're going to be watching Perseverance, and it is going to be so exciting. So I will talk to you later. I hope you enjoyed the book.